Okay. Hi, Abby. I'm trying something different this time with my recorder because usually it sounds a lot clearer, and I don't know why on the other videos it was so like scratchy in the background. It was weird. So, anyways, I wanted to finish up those couple of things that I was talking to you about last time, the couple of questions that we skipped over. We stopped here last time, and I was showing you that I know you can find this. And I showed you how, we were combining those like terms to find the value of x by remembering that all of those pieces of this circle here are going to equal up to 360 degrees. Okay, so I'm also very curious how that went for you, so I want to hear from you about that. But anyways, so then we were moving into the other problems that you sent me right here, where it was talking about finding the length of the dark arc that is, I keep using my hands as if you can see me. Let me use my mouse. Finding the length of the dark arc that's shown right here. Okay. And then you have this one here that's asking you to find the length of the dark arc that's shown right here. Okay. So I want to talk about that because there are two ways to find the answer to that. Okay. So you can find arc length in a measurement of degrees, or you can find arc length in a measurement of radians. I know that sounds crazy if you have not approached that yet, but when I'm looking at your problems, I notice first off that your teacher asked you, look, and I don't have my phone, your teacher asked you to round to the nearest, I want to say 100th, check your paper. It was 100th or 10th. So that leads me to believe that you guys are going to be finding this arc length in degrees. Because if you're finding arc length in radians, you're not going to be rounding anything, just so you know. So I'm going to show you this of finding arc length in degrees. And then I can make you a separate video on how to find it in radians, because that's also a very useful tool and way, because you're going to eventually have to know how to do it. And it has a lot to do with this unit circle here. I don't know if you have seen yet a unit circle that shows you all of the different degrees and radians. That's going to be another really useful thing if they have not already given that to you. So just to kind of show you really quick. So your unit circle, if you look at it over here, open image, a new tab. Here we go. Oh, why is this so small? Of course it's so small. How do you zoom? Here we go. So this unit circle, if you look at it, you've got your circle that's divided up into all the different degrees. Remember, we talked about how it's divided in half. It's 180 degrees. See this 180 right here? And then, once you divide it into quarters, you've got your 90 degrees. And it's very interesting because this unit circle will already be able to show you some of these things in radians. That is going to mean the same thing as degrees. So if I had something that said, let me see what this example problem is going to say, 135 degrees. I don't know if that's going to be on my unit circle. Probably not. Oh, it is. Look, there we have it in radians. This is it in radians, 3 pi over 4. So when you do something in radians, you don't do all of the math all the way, which is kind of cool. I really like to find things, find these arc length in radians, because you just get to leave it at that. You don't really have to do a lot more math past that. But because I see your teacher's asking you to round to the nearest, whatever it was, 100th, 10th, millionth, I can't remember. Look at your problem. I know she's looking for you to be doing this in degrees. So I am also going to attach a video on here, which may be on my drive. I think I uploaded it to my iCloud drive, because if you are going to check your work with your graphing calculator, there is something very important that you have to make sure of on your graphing calculator. Okay. So if you are solving your problem, looking at your arc length, and you are finding your arc length in degrees, and you're going to check your work with your calculator, I made you this quick little video wherever you went of how to make sure that your calculator is in degrees. And why is it taking so long to download? It's like a 1-minute video. Okay, well, we'll let that download. But that's something very important, because you have to make sure that your calculator is set in degree mode, because your calculator, I don't know if you knew that, can be set in radians mode. So it's definitely something you want to check before you start plugging anything into a calculator, to kind of, go back behind yourself and look at what you're doing. And I, in this video, showed you how to look for that in your TI-84 calculator, if you so happen to have one, the graphing calculator. And it looks like it's almost downloaded before I get into this. There we go. So here's our video. Hold on. This file isn't playable. You are terrible. Really, 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 really. Okay. Well, I'll figure out how to get it up there. You've got to be joking me. And I don't even have my phone either. Anyways, so I'll send you that. But make sure your calculator's in degree mode, and I'll send you that video. So let me stop rambling and get into this. Finding arc length in degrees. Finding arc length in degrees. You have a formula. Okay? It's always going to be the same formula for finding it in degrees. You're going to be given a problem that shows you a circle, okay? And it's going to offer you a radius. Sometimes it might offer you a diameter where it has the line all the way straight across, and you would have to, go ahead and divide it in half to find out, what that radius is, right? Okay? But in your problems, you're lucky they gave you radius only. Okay, so you're good to go there. But your formula is going to be 2 times pi times the radius, and then you're going to, in parentheses, you divide the central angle divided by 360. Okay? 360 degrees, because we've talked about how our whole circle is 360 degrees. So I also am not sure if you've seen this symbol, and it is driving me bananas. I cannot remember. I know it's a central angle symbol. So if you ever see this symbol where it is a circle with the, perfect straight line through it, that is the symbol for central angle. Sometimes you also might see symbols that look like this, where it looks like the L, and then it's got the extra little beep like that. That's an angle symbol right there. It's showing you, angle. That's an angle symbol. But this specific one right here with the circle and the line through it, that is the central angle symbol. It's got a name. I feel like I keep wanting to say it's Theta symbol, but I don't think so. I think that's just some sort of philosophy from Socrates. I don't know. But that is your central angle symbol. So what you're going to do, I have an example problem here that I'm showing you first, okay? So your example problem here is giving you a circle here that has a radius of 10, okay? And the central angle is 135, or 135 degrees, okay? So for me, and this is something that I was taught literally in 7th grade, and I will never forget her name, by Miss J. Davis, and it's too funny that I ended up being a Davis. But Miss J. Davis in 7th grade told me it doesn't matter if I have a formula memorized when I'm doing a problem to write it down anyway, to literally write down every single step of my problem as I go, because then I will ensure that I don't miss any steps. Like, don't try and tell myself, okay, well, I already know that, and then skip ahead and, just do that. She told me every single time, write out every single solitary step and then fill in what you know step by step, as annoying as that is. But I love her for that, because it always makes me be sure that I get all of the information plugged into my formula. And when I learned that in 7th grade, when I was, doing Pythagorean theorem and stuff like that, And then when I got to pre-cal and calculus and stuff, and I started doing this crazy business, that it helped me so much, because you end up having such long formulas that if you do it step by step and fill in what you know, step by step, as annoying as it is, you won't miss anything. Okay? So, step 1, I'm telling you to write out your formula. Okay? So on this first slide, I showed you that arc length in degrees, that is the most important thing, Abby, right here. This is only if you are solving it in degrees, not radians, in degrees. Your arc length formula, 2 pi r times central angle over 360. Okay. So step 1, write out that formula. Doesn't matter if you got to memorize, Abby. Write it down. Step 2 is when we're going to start filling in what we know step by step. So what I do is I start going across the formula and I fill in what I know. First time, I'm coming across my formula, 2 pi r. Do I have r? I do. It's right over here, 10. So I filled in my 10. And notice as I continued across, I still kept that central angle symbol there from my formula over 360, and then closed my parentheses, equals, we don't know yet. Then I wrote it again. I carried down all this information that I wrote down from my formula already that I have now plugged in, this 2 pi r and my 10. Okay, so I carried those two things down. Look at those green lines. They're still there, Abby. I don't understand. Who wants a green line? I want it something other than green. Like, you can't see it. Make them red. Okay, so I carried those down. And then, as I continued to write my formula, now I can see, oh, I've got something else that I can fill in. I can fill in my central angle now. So my central angle told me that it was 135 degrees. And I have my equal sign. I'm not going to solve it yet, okay? Because we're going to do it step by step. Because if you try to plug it into your calculator, these calculators, these graphing calculators, as I hear a plane flying. I don't know if you can hear it on my recording. I'm so sorry. These graphing calculators are very useful, but they're very touchy. So sometimes if you plug things in and you do not have parentheses in correct places and whatnot, you're gonna end up with a funky answer. So it's best to still be writing it out by hand, but you can use your calculator to help you do each step. Don't try to plug the whole formula into your calculator, because I promise you it's probably gonna give you the wrong answer. So on my next slide, I just carried over what I had right here. I carried it over. So what you're going to do is you're going to want to do this first portion in your calculator and find out what that is first. So you can plug that in. You can do 2 times pi times 10, and it's not going to give you something funky. So I'm not sure what your teacher prefers. So make sure you know what your teacher prefers. Does she prefer for you to actually use the pi symbol in your calculator that, actually gives you the accurate number of pi? Or does she want you to use the rounded version of 3.14? I'm going to go ahead and use the rounded version of 3.14 just to make it easier for us right now on the screen. Since you can't see my calculator, because you can't see my calculator video. So mad. So what you're going to put in your calculator is you're going to say 2. Oops. Let's make it bigger so you can see it. You want to see it. I am going to do 2 times pi times 10. I'm going to find out what that equals first. Okay? So let's see. Let's pull up my regular calculator for you here, because I don't need my graphic calculator for that. 2 times 3.14 times 10 equals 62.8. Okay, 62.8. All right, you know what? And I actually am going to make that smaller so that it fits. Or no, Can I make this bigger? No, I'm gonna make this smaller because this is a whole mess. You don't even know what it took to get that thing there like that. Happy. I'm gonna put it right underneath here, okay? So we have this right here, 2 times pi times 10 equals 62.8. Now what I'm gonna do is I am going to write it out again, my formula, but I can fill in this portion right here that I just solved. So what I would do is I will insert, okay, not insert, sorry, I was talking to myself because I need a text box. I will write 62.8 because I have that portion now, because 2 times pi times 10 equaled 62.8. So 62.8, and then let's see if I can capture all these pieces. It's so weird how I had to set this up. Let me give, okay, that's a text box right there. So let me get you. And I want you. Oh, am I going to get you? I want you and you. It's probably not going to let me. Ooh, will it let me do it like this? Ah, go back. I'm sorry, Abby. It's so complicated the way that I had to do these. Oh gosh. Let's see what that does. Let me paste that over here. Get rid of you. Oh. Get rid of you. Put you back over here. Oh, I know why. That's a whole separate text box, so you can go away. Delete. All right, so let's get this 62.8 down here. 62.8 times central angle. I'm sorry, it's taken me a second. It's what this is the hard part about creating the more difficult calculus formulas on a computer screen. I probably should be making this by hand and just showing you on paper. That'd probably be best, but it is what it is. So 62.8. We're gonna make you bigger. Get bigger. Hello. Bear with me, Abby. All right. I am so sorry. There we go. 62.8 that we got right here. We carried it down. Okay. And then we rewrote it with the formula piece again. I don't care if you know this, 135 by 60. Did I have that in there? Yeah, I filled that in what I knew step by step, so I should have that 135. So I'm going to change that central angle symbol here to 135. Oh my good golly gracious. You're going to kill me. You're going to be like, this is not helpful at all. What are you doing, Miss Davis? $135, 10176. Abby's like, what are you doing? It's so bad. Miss Davis, you're just not getting it together here. The other video was so much better. No, I'm just kidding. Okay. And you know what? I'm just going to use the pencil because it's easier. Here's my parentheses. And here is my parentheses. Okay, so we have 62.8. My good golly gracious, we've said it 1,000 times. Times 135 degrees divided by 360 equals, we don't know. Now, you don't want to just go ahead and start plugging that into your calculator either. It would be best if you carry down again that 62.8. You did it again, and we're going to put it right here. You know what? Here, Abby, I got you, because this is what I'm going to do. This is going to make it easier for us, and then I'm just going to paste it into our little thing here. Okay. And I'll go back and forth. I'm sorry. It's too hard for me to draw on a PowerPoint like that because it's going to keep on taking away my pencil every single time I do something. So, let me make sure I have not confused you entirely to death. We said we write out our formula, 2 pi r times central angle divided by 360. Step 2, fill in what you know step by step. So, first step, 2 pi r. We had 10. And then I continued writing my formula. Even though I see that 135 degrees and I know it goes there where that central angle symbol is, I write it again anyway because it's going to help me remember my formula. Then I wrote it again. And then I filled in the next portion that I have. I have my central angle, so I filled it in, that 135 degrees over 360. And that's where everything went crazy with my PowerPoint, my good golly gracious. And so what we did first, I said, was we solved this first half of multiplication that's on the outside of this parentheses. So 2 times pi times 10, which equaled 62.8. Now I brought it over here so I can write. Now what you're going to do is, it's going to be best if you solve now what this equals. Okay, this 135 degrees divided by 360. Okay, so I'm going to plug that into my calculator here. Let's see. 135 divided by 360 equals 0.375. Okay, 0.375. So I'm going to write that. But I'm going to keep my parentheses here. 0. I know it's ugly. 375. Okay. I need to bring this with it. This 62.8. 62.8 equals. Now I can multiply these. So 62.8 times 0.375. Let's see. Oh, why didn't I leave that there, Abby? I could have just... Man, that's all right. Times 0.375 equals 23.55. 23.55. Now, you're going to have to remember, if they give you a specific unit, do you need that unit or do you need your degrees? Let's see. Here's my little thingy here. Arc. This is also, just so you can see what I'm typing in here, the tutorial that I found that I thought was most useful. Arc length formula, arc length in degrees. Because what's really cool is that this little website here, if you type in arc length in degrees and scroll down, it had this one, this WikiHow that says how to find arc length 10 steps with pictures, is awesome because it will also show you radians as well. And that's where I got my example from. Let me make sure I solved this correctly. What's the answer? 23.55. I was right. Okay, so we're cool there. So that is how you solve for arc length in degrees. Where's my PowerPoint? And I know I made that crazy complicated. So what I'm going to do is I am going to figure my life out here, and I'm going to send you one more video. Oh, look, see, this is where I was going to put my answer for my beautiful problem. And I don't need that slide anymore. I'm going to send you another video now that's going to be talking about the 2 problems that your teacher sent you. Okay. Oh, that's what I was looking for on this website. Did it say anything about what you need to list it as? 10 centimeters, 23.55 centimeters. Yes. Pay attention. Did they tell you? So where'd you get that centimeters, homie? Sorry, I'm reading. Because I noticed you have a different, so the length of the arc of a circle, radius of 10 centimeters. Okay, he did not have centimeters written in his thing, so I don't know where he got that centimeters from. But that's going to make a big difference in making sure that you write down what your unit was. You know, whatever unit that they gave you, like how your teacher says yards or your teacher says, you know, feet, centimeters, whichever. Make sure you're paying attention to that when you write your yeah, like I see this one here talking about meters, you know. Pay attention to what unit length they give you, because that's part of your answer. And sometimes in those online courses, if you don't list your answer, like you just said this, but you didn't include whatever unit they gave you, like in your example here, feet, then it might be considered wrong. So you have to be very careful about that. Okay, arc length was 23.55 feet. Okay, not just 23.55, because that can mean anything. So pay attention to what unit they give you. Now, if they don't give you a unit, you would just say units. You know, you wouldn't say feet. You would just say units. You could use a U, or sometimes you can type out units. Make sure you talk to your teacher about that. So I'm going to end this video, and then I'm going to send you another one that actually talks about the 2 problems you sent me, so we can see. Actually, no, I'm going to talk about this first one, and you are going to solve this one by yourself. And then after that, I would like to talk to you about how to solve it in radians, because I'm not, unless you tell me that you guys have not touched that. If you haven't touched it, then I won't send you a tutorial on it, but that may be what you're leading into very soon. Okay? So, how do I end this thing? Let me end it with the formula sitting right here, Abby. It's over here. 2 pi r times central angle over 360. And man, ask your teacher what that central angle symbol's called. It's driving me nuts. All right, I'm going to stop this and send it to you. Okay, bye-bye.